All right, so I think we should get started in here. Okay. So good morning, everyone. Morning. Um, excuse me. Um, a couple of things. Okay, number one, the midterm is done. Yesterday, I was looking at the midterm today. It feels like we're doing very well in the midterm. The average of the midterm is like 80%, so we're doing good. You can see the midterm on Grayscope. You can see it over there. Okay. If you have any questions about midterm, you say, okay, I think my answer is right, but I didn't get the credit. The best way is to ask on add stem. Okay. So we should be able to answer it because everything is auto-graded. Really, there is no grading error. The only possible error is our rubric is wrong. Although unlikely, but it's possible. So if you believe that the rubric is wrong, submit it on add stem to say, can you explain to me why this is wrong? Or like, I think my answer is right. Why did I lose points? We'll be happy to explain to you. In the event that we say, oh, we made a mistake, the rubric was wrong, we will go back and regrade that question for every student. Okay, so no one should be penalized for wrong rubric. If we say, sometimes it happens to say, like there's no correct answer, like our rubric is so wrong that there's no correct answer for that problem. If that's the case, we'll just give everyone credit for that problem. So again, one way or the other, no student will be penalized for wrong rubrics. Okay. So take a look at the Grayscope and ask questions on add stem. Grayscope has this regrade request functionality. It is not very convenient for us to respond over there. And since everything is auto-graded, there's really no need for you to use the regrade request on Grayscope. Just ask questions on add, and we will take care of things from there. Okay, that's one thing. There was no lab yesterday, so that was good. So we have that was what we have. Let me see. The midterm is published now. You can see it now. Okay, so it should be available at this time now. Okay. The next thing is quiz. So we have a quiz tomorrow. Okay, so make sure you complete the quiz. It's a normal quiz. Okay. Altogether, we have 4 quizzes this week and the next. There's no quiz for week 5. Okay. Also, we have our PA due this Sunday night. There was some issue with the concept questions, but it should all be taken care of. I tested, it seems to be working. Okay. So you should be able to submit the concept questions for PA3 and beyond. Okay. I think that's everything I want to talk about logistically. Are there any questions here that folks want to ask about the logistics? All right, then let's get started with the material here. Okay. So the plan for today is we will process pictures. We'll be looking at number 1, filtering. Number 2 is mirroring and flipping. So it's either you process the picture in a kind of a, like change every pixel in a certain way, that's called filtering. Or the other way we can do is we can try to manipulate the picture geometrically, that's mirroring and flipping. Okay, so that's the topic for today. Okay. Last time we did a demo of like how to use the CSE 8A image library to manipulate pictures. At its core, we basically process this 2D list of tuples. So image in general is a 2D list. This is the row number 1, row number 2, 3, and 4. If you type this into Python tutor, this is what you will see. The image is a list. Each of the element in this list is another list. So it's a 2D list of tuples. So each of the element in the second level list points to a tuple object. So the first row is 25500. This is basically image 00. And the second one is 00255. That's image 01, and so on. So when you try to think about the 2D list of tuples, you need 2 indexes, right? So we have image ij, and I want you to definitely think about this as row number, column number. So this is the row number. This is the column number. Okay. And that's what we do when we try to process a picture. We just go through the image. If we try to do a filter and try to change the RGB value of that tuple. Remember, as these are tuples, you cannot change this tuple object. A lot of times we say, if you want to change this color, you kind of create a new tuple. For example, it's like 100, 100, 100, and you let this thing point to it. You cannot go inside the tuple and change its values. You can't. But you can definitely create a new tuple and let this reference point to the new tuple. Okay. Any questions about this part? Okay. So let's look at this one. So normally the way that we process a picture is, first thing, you have to use load or create image. We either create a blank canvas or load an existing picture. And sometimes you have to load in multiple pictures. Like later on, we're going to look at this thing called steganography, where you need to load in 2 pictures at least. And today, maybe we can do some demos of manipulating 2 pictures. Okay. And then you get to the dimensions of the picture, how tall it is, how wide it is. Basically, the height tells you the number of rows. The width tells you the number of columns. Okay. And then you use a nested for loop. In general, the reason why you need a nested for loop is to give you I and j. So you take out the RGB. This is unwrap. So you kind of obtain the RGB value of that pixel, and then you let image ij to point to a new tuple that you create. Remember, this thing is a reference. Okay, that's a reference. That's not the tuple itself. It's pointing to a tuple. Okay. Any questions about this? So these are some of the functions that you can use. We've done some demos on this on Tuesday. Now let's do a quick coding exercise. Okay. I think I demoed this one before, but how about we do this? Can you write a function? This instead of call this red filter. Let me go to add here. I'll give you the link. Let's see, week 3, Thursday. Let's look at this red filter. Okay. So how about instead of call this red filter, can we try to do a green filter? So this is the code that we want to write. So I call this green filter. You want to basically wipe clean all the green of every pixel in the picture. Okay. I think in here you can have a bear.jpg. This is the engineering bear. Let me see if I have this in there already. Yeah, we have them. So when you come to this you already have access to bear.jpg or swan.jpg. You can just filter out all the greens, okay, and test your code. You also have access to CSE 8 image.py. Make sure you import that, okay? So follow the link, go to add and work on it. Give me a vote once you're done reading, like finishing the code, or you say I give up. You can also vote in. Okay, so take some time, try to write this yourself. Okay, so get started, folks. Work on this coding exercise. Okay, vote in once you get it done. We did something very similar like this on Tuesday. We did the red filter, but if you change this into green filter, what would you do? You can't just look at me code, right? If you just look at me code, you are not gonna get better. Just like you can't go to a gym and just look at other people work out. You have to do it yourself to make yourself better. Okay? One of us is done. Okay. And you want to make sure that your code runs and works, right? How do you verify if your code works? For those of you who are done, they say, well, how do I know if my code works? You can't just say I will eyeball the picture. It's not gonna work. Okay. For easy things, possibly, but for complicated filters, you won't be able to do that. Once you finish or once you give up, vote in, please. Okay. No, it's not gonna work. Then you can vote in. Okay. Or say I'm done. You can vote in too. Keep trying. Okay. Sorry. All right. 5 of us are done. All right, so let's work on this together, right? How does this work? Assuming this image is a 2D list of tuples, right? It's a 2D list of tuples. So what we'll be doing is you want to know the number of rows equals to the height of the image. The number of columns equals to the width of the image. I'll try to avoid using XY at all costs because it's confusing. For the red filter, I'll say for I in range of number of rows. Just be careful. I think last time I made a mistake. If you use R also stands for red. So you may like if you use C for column, C also stands for like potentially like especially R. I think C in general doesn't give us trouble because R can stand for row, can also stand for red. So just be careful. Okay. So I would just use I in here. For J in range of number of columns. And I'll just grab the RGB out from this pixel at the location IJ. And then I will just write it back, but I'm not gonna give you any green. And that's it. This would change the picture. So let's say load image. Don't forget to import here. From CSE 80 image import asterisk. So load image. I'll get bear.jpg. And I say picture equals to this. And I just pass it to green filter. So, okay, I'll give you this picture. And then I save image, give you the pic, and this one is no green bear.jpg. Okay. So we can run the code python filter.py. And this is the original bear. This is the one with no green. Well, I don't even know whether it's right or wrong, right? It looks red now. It looks red. How do I know this? I mean, if you're not sure, which most of the time we are not. So I'm not sure whether this is right or wrong. You should always save out. Sorry. You should once you read in the image, there's this image string to file. Okay, let me write this picture. I call this original dot txt. This is kind of the original picture's top 20 by 20 region. And then I write it again. This is to say modified txt. This is the only way you can be sure that your filter is working. So if I now run it, you see the original.txt, like this is the top left pixel of bear, 68, 72, 47. You look at it here. This is the modified. Nothing else changed except the green component is gone. So it is right. This is the only way that you can be sure. Any questions about this exercise? All right. So this is the first exercise. I don't see any questions. We will move on to the next one. So this is the first exercise. Normally, if you are doing complicated transformations, the first thing you want to do is you want to start with something very small. Okay, if you say I want to do a filter, I want to do something. Sometimes a big filter is easy, right? Filter in general, every pixel is applied with the same logic. But sometimes when you try to like mirroring or flipping, things get complicated because different pixels would have different changes. If that's the case, you want to kind of start with something small, right? So try to create pictures that is not square, because like you may have even with like a picture of 2x5 or 3x7, create some weird shaped pictures and see if it works. Okay. Make sure that your code works on small images because you can calculate the effect by hand and then test your code against real images. Okay. Check for boundary cases, like what if the width is even? How about if it's odd? Does my code work for both situations, right? So you should handle those edge cases in a special way. Okay. Are there any questions? So here's one exercise. So I have this region. This part is not accurate. I want the right side to be blue. This side. Okay. So let's just look at this one. This region, I want it to be blue. And this can be any picture of any sizes. This is just one example. So your code should work for pictures of all the different sizes. I just want to color the right half blue, pure blue. Okay. If it's like odd width, like if I have three things, then you only cover the you leave the middle column alone. For example, if you say I have a picture with 3 columns, you only cover this region. Okay, you can leave the middle column alone. You don't have to cover it with blue. Okay, so let's think about this. What should I fill in here? Blank number 1. Vote for this one. Okay. All right, so we disagree with each other quite a bit here. If you look at the votes, A and D dominating here, none of these answers. Let's check. Right. So what should I the range? What should be the range? In other words, I want to change every pixel in here. I is a row number because it appears as the first location of the 2D list of tuples. So I is a row number. So what row should be covered? How many rows? The entire group of rows. So the number of rows is H. So the answer is A. All the rows. All the rows. Any questions about this? All the rows should be covered. For those of us who voted for D, of voting for B, you got it the other way around. So I is for the row number because it appears in here. It doesn't mean I can only be row. I can put J in the first location too if J is indicated as row. So you just have to look at what variable is put in the first part. This is always a row information. It can be the total number of rows, or it can be the index of the row into a cell. Okay. Questions about this? How about this part? Answer for blank 2. J obviously is for columns. All right. We will stop the vote. B and the D dominates in here, B or D. So this is kind of, at least we're looking at columns, right? So that's good. Now, which region of the column should I work on? So it's this region, right? Is it, well, how do I know whether B or D? Well, number one, I'm not going to cover the entire width, but I would say B is incorrect because B would allow me to cover the entire width. I only need to cover the right side. So for those who vote for D, we're covering half of the width. All the way to the end. So if you look at this part, W divided by 2 to W is like half, right? So sorry. How come there are so many people calling me today? I never have anyone calling me. Sorry about that. Okay. So what we have in here is, for example, if the width is like 3, I only need to cover the last column. I only need to cover the last column. Okay. The way to take care of it is to say, well, if I start with 3 divided by 2, this thing, in fact, has a decimal. And that's not good. That's not good. So for those who vote for D, say, half of the width to width. In fact, half of the width, you should use double divide. Double divide. So if it's odd, in here, if I only take care of the last column, it should be W divided by 2 to W. If it's even width, like for example, I say 0, 1, 2, 3, so 4 divided by 2 is 2. Even width would work out just fine. Odd width, I have to divide by 2, then add 1 to it. So how do I do it? If you only want to cover this single region on the right side, if the width is odd, all you need to do is do this, W plus 1 divided by 2. It will work for both even and odd. For odd, if W is 3, 3 plus 1 divided by 2 is 2. If W is even, which is 4 in here, 4 plus 1 divided by 2 also equals to 2. So it's going to work all the way to W. So the correct answer, in fact, is E. None of them is right. This one mostly is because of the division. You should use double division instead of single division. Okay. Any questions about this part? Just be careful. At least we identify it should be W. That's a good improvement. But you have to be careful with the division in here. You may be off by 1. Because if you simulate W divided by 2, you're going to cover this column as well. But that's not good. Okay. Now, what should I put into blank number 3 here? What should be blank number 3? This part is easier. Okay. I would expect most of us to be able to do it. All right, so we'll stop the vote. A majority of us voted for B. That is the right thing, right? It's all blue, so that's what it is. Any questions about this? What does A do? A would just make everything blue. Sorry, only keep the blue component. You only keep the blue component. It's different from making everything blue, right? So you can, if for example, if you see the bear, this one would, you still see the bear, but you only have the blue components of each pixel. This one, you won't be able to see the bear anymore, just masked with pure blue pixel. This part is in fact gonna make the picture darker because each of the RGB values are half of what it used to be. Okay, so B is the right answer for this one. There's one question. So one of you said your load image doesn't work. And based on what I see here, you need to type in the right image file from CSE image, not any abbreviation. So uppercase, lowercase has to be exactly the same. You have to import the right thing, then your load image work. Okay. Any questions? All right. Now, how about this one? So change image threshold. What does this one do? What does this one do? Let's let us so make the top half darker. Okay, top half darker by this threshold. If threshold is dot 3, you multiply every pixel's RGB value by dot 3. Okay. If its threshold is dot 9, you multiply every RGB value of each pixel on the top half by dot 9. Top half is defined as, you can think if it's even, then it's the top half, right? If it's 4, the top half. If it's odd, top half, you can just say it's the one up on the top. It's easier in this way. Okay, so this is the even part, this is the odd part. And if you do the right math, these two parts can be taken care of by the same math equation. Okay, so here is the link to this coding challenge. Darken the top half. Okay, so it's this one. Here's the link to the problem. And again, work on it and vote in once you're done. Okay, the top half. only the top half, right? It's the same thing. Don't forget to import. I think I have the file in there. Yeah. One of us is done. Okay, which is very quick. Top half, you got to specify the region. The nested for loop, you can also imagine it specify the region you want to process. So if you say top half, then you got to specify the top half. So what is the range for the rows? What is the range for columns? And that's your guideline to say, okay, this is how I should construct my nested for loop. Two of us are done. All right. It's 4 minutes to our exercise. Only 3 of us, no, 4 of us are done. 4 of us are done. I probably didn't give you enough time. This one is not very straightforward. You have never done anything like this before. Okay. So uh, let's work on this together. Okay, work on this together, and then we'll take a break. So change. You first want to know the number of rows. This is almost standard now. You get the dimensions, right? Height of the image, and then number of columns equals to the width of the image. And then I need to specify the box. I need to specify the box. This is where you have to specify the the idea like this, right? So I need to, like, for example, if this is what I have, if the top half, right, we say it's just this thing, which is just 0, right? So if my height is 3, h divided by 2 would give me a 1. So if I say range of height divided by 2, this will give me a 0, right? This one would only go from 0 all the way to 1, but not including 1, so just give me the right thing. If I have 4 rows, I need to take care of this region. Now height is 4, range of h divided by 2, 0, 1, 2, 3. So this one looks like a W. Right? So this is h, right? H divided by 2. So 4 divided by 2 is 2. Range of 2 is 0 and 1. So exactly what I'm looking for. So this will be my row logic. You got to think about this. So it's a for I in range of number of rows divided by 2. Make sure it's double divided. Column is just all the columns, right? For j in range of number of columns. The trickiest part is this region. And then I grabbed RGB out. And the next thing is I need to manipulate these RGBs. It's going to be multiplied. So R equals to, make sure you typecast it, right? Because threshold can be a decimal. R times decimal would be a decimal. The RGB values of a pixel must be a whole number. So you have to typecast it into an int. Similarly, B equals to int B times threshold. Right? So now I'm ready to save it back. I'm done. Okay, so this is the code. Let's say, well, how do I test it? You do not want to test it on bear directly. Let me create a picture, right? So let's say image 1 equals to create image. Height is 3 by 2. The 3 rows. Create image. Height is 3, 2 columns. And everything is like 100, 100, maybe not 100. 100 is too nice. 111, 222, 97, right? So some weird numbers in here. I created this image 1. I'll print it out, right? So I'll say image string to file. I'll say image 1, and I'll save it as image 1.txt. So this is the original picture. It's a very tiny picture. And now I would call this function change. I pass image 1 and say 0.7. And now I will save this image to string file again. Image 1 has been changed. I'll say this after image 1.txt. And I just want to see if the values make sense, right? So it's Python darken.py. Let's look at it. So image 1, this is with 3 rows, 2 columns. And I only need to make the top row darker by that threshold, 0.7. So how do I know what the value will be? You have your calculator, right? This is programmer, not good. Scientific is better. So you have 111 times 0.7 is 77, right? We throw over the decimal part. So I would expect 77 222 times 0.7, 155, 97 times 0.7, 67. So I'm expecting 77, 155, 67. Let's check. 77, 155, 67. So the first row is changed. That makes sense, right? But okay, now how about this? What if I have a even height? If it's 4, if I run it again, image 1 is 4 rows, right? So I expect these two to be changed. If you look at after, these two are changed into the right value. Now you are sure, okay, my code works. This is when you can have fun to say, okay, there we go. We can also try to say image equals to load image. I say bear dot jpg, and then I say change image with a 0.5% darkness, and I save image. So save this image as darker bear dot jpg, and that's it. You run it. You will see the original bear. This is the bear where the top half is 50% darker. All right, does this make sense? Any questions? The most important thing here is make sure you know how to test it. Okay, yeah, there is a question.
Why are we multiplying by 0.7?
Because the threshold is 0.7 that we pass in. Whatever the threshold you pass in, you should do the math, use a calculator or by hand to see what is the value that I'm expecting, right? Because I pass in 0.7. If you pass in 0.5, then you should calculate the result by 0.5 and see if your answer is right.
So for the threshold, we're able to assign whatever like value we want.
Yeah. So
for 0.7, you assigned that yourself. So that's why we're doing divide by 0.7.
Multiply by 0.7. When we call function, this image 1's value is given to that image. This 0.7 is assigned to the threshold of the function. This is how the function is called, right? So that's why the threshold in this function call, we treat it as 0.7. In here, we treat the threshold as 0.1 because this 0.1 is given to that threshold.
Okay. Yeah. Thank you.
Any other questions?
Yeah, I have a question. So
Okay.
for this one, for I in range num rows over 2, I'm wondering, like in the last one we did it was like, I think W.
+1.
Yeah, it was, I know it's like odd and even. But like how come this time we don't have like a bounds to it in the range?
It has a bound. This is the bound. It goes from 0 to this bound.
Oh, so like it goes to the whole thing, so it doesn't have to like, we don't have to put like num rows over 2, then a comma, then num rows. We don't have to do that.
It depends on how you define your range, right? So in here, we'll only look at the top half. So it means going from 0 all the way to h divided by 2, not including h divided by 2. That's why we're using this range. But if I need the bottom half, then it should be h divided by 2 to h. It depends on which half you're looking at.
Oh, okay. All right. Okay. Thank you.
Any other questions? All right, then let's take a break, everyone. Okay, come back at 12. We will continue our discussion of image processing. Break time, break time. Okay. All right, folks. Let's work on the second session. Okay, the second session. Let's see, where's our PDF? There it is. So the second session is about mirroring and flipping. Mirroring and flipping is, I would say, is a trickier topic. Just like in general, geometry is harder for humans than algebra. Right? Algebra is mechanical. Human brain is pretty good on it. But geometry, a lot of times we just struggle with it, and mirroring has something to do with geometry. Okay. So we'll spend some time on this topic, and then again, if there are any questions as we talk about these concepts, just ask. Okay, it's not too bad. It's not too bad. So what is mirroring? Mirroring means you kind of change a picture. This is the original picture. You say I have a axis symmetry, like in the middle, vertical axis. You can mirror from left to right. This is what you end up with. You can mirror from right to left. This is what you end up with. So, I mean, it's not a perfect mirroring result, but you can see, roughly speaking, it's like this. Okay. So this is mirroring. You can also have a horizontal axis, you mirror in the middle. That's totally fine too. Okay. So that's what we'll learn. How do I mirror a picture? And the mirroring of a picture is related to the dimensionality of the original image. So one of the key concepts for you to manipulate a picture geometrically is the coordinates. And you have to be very careful because all the indexes, all those indexes start from 0. Okay. So here's one example to mirror from left to right. Given the original picture, mirror from left to right. As the image width is the width, image height equals the height, and the mirror point equals image width divided by 2. Image width divided by 2. And then I have this nested for loop. Well, how do I know I is for row or column? You look at where I is used. I is used in the first dimension in this row. So we're going through the entire height of the picture, right? If you look at this range, it goes from 0 to image height. If you just have one number in the range, it implies it goes from 0. So we're covering the entire height of the picture. Now, for the columns, it goes to half of the width, right? Because range of image width divided by 2 is half of the width. So we basically said, this is the region I'm specifying. This is the region. Sorry, my dog is barking. So this is the region on the left side. So we grab a pixel from the left side. I say RL, GL, BL means the left side RGB. I will copy the exact same pixel to a different location, So what is the other location? If you look at this this part, let me erase this part a little bit. Sorry, it's hard to erase things on a PDF. If I have a pixel in here, this pixel is IJ, then the corresponding pixel would have the same row number. The column number is width minus J minus 1. That's what it looks like. I'm copying from one pixel in here to another spot on the right side. Okay, this is to mirror from left to right. Okay. Are there any questions? All right. So you basically copy every pixel in this region to the right spot on the right side. And this is something we hope we'll end up with. Okay. Let's first look at this example. Given this code, if we have a picture whose height is 50, width is 100, we use this one to copy from left to right. What are the locations of the first three pixels that we will copy? For I, for J, like the first 3 pixels, this is the one on the left, this is the one on the right. Which coordinate pairs are are good, or E, none of them. If the height is 50, width is 100, what is the coordinate, not coordinate, what's the row column number of the left pixel? What is the row column number of the right pixel? We copy it too. So can we work on this? Okay, what are the first 3 pixels that we copy? All right, so let's look at this one. Okay, so the most popular choice is B. Let's check. So the first pixel in here is 0, 0, right? Because this one starts from 0. This range also starts from 0. So it's 0, 0, which is this one. And then it will be copied to hopefully this spot that should be mirrored over there. And this one, if you look at the coordinate of the row column number of the target, you should, so this is 0, 0. Then it's going to give me the same row number, but column number is width, which is 100 minus 0 minus 1, which is 99. So 0, 0 will be copied into 0, 99. And then the next one, I would stay the same. In other words, row number would stay the same. The column number is increased by 1. Column number will be copied over here. This one will have the same row number. The column number is 100 minus J minus 1, which is 98. I say B is the right answer in here. Okay, so it looks like it's going to work out. Basically, the idea is I'm going to copy everything in this first row to the corresponding spot on the right side. We say, wait, 0, 0 to 0, 99, where's location 0, 100? Remember, you don't have location 0, 100. If you count from 0, 0 to 99 would cover the entire 100 pixels on the entire width. Okay, so just be careful. There's no column 100. If the picture's width is 100, there's column 99. Okay. Any questions? All right. So that's the first exercise in here. Just be careful, be patient, and you have to understand how range works, how for loop works, right? When you are looking at this kind of geometric processing of a picture, the number one thing is come up with some small pictures. Don't make a nice picture 10 by 10. In general, it's not a good idea. It's a 5 by 7 or 6 by 5, something like that, right? So check for even width, even height, odd width, odd height, or any combinations of them, and see if your source and destination coordinates. When I say coordinates, I really mean row column pairs, okay? You try to write it out and see if the pattern works out. For example, if you say, I have a picture of 3 by 4. If I say mirror this picture from left to right, I need to make this copy. Sorry. I need to, the other copy that I'll make is this part goes over here, this part goes over here, similarly like this, right? You make sure that your math would work out fine, right? If your math doesn't work on the small pictures, then you got to change your math. Normally, you are looking at like dimension divided by 2, like either height divided by 2 or width divided by 2, or dimension, which is like row or column -1 or something like that. You have to be careful. Remember, there are 3 ways you can do the range. If you range A, it means goes from 0 all the way to A -1. If you say range A to B, you're looking at going from A all the way to B -1, right? So be careful in here. If you only have one number, that will give you a 0 to start with. Okay, so make sure you fully understand the range and your math would work out. And that's it. Patience, and also make sure you don't say, oh, it works on this test case, I'm ready to code it up. You're going to be in trouble, I can tell you, if you're not experienced. You may miss a column. Like, for example, how do we grade your work? If we ask you to do a picture processing assignment, you say, okay, we need to grade your work. And if you say, I say, mirror the picture from left to right, and your code mirrored, it looks like it's mirrored, but it's missing a column, then you lose all the credit for that test case. You can't be off by 1. You can't be off by 1. Okay? So it's very strict. Make sure that you test your code on even width, odd width, even height, odd height. Make sure everything works. Okay? Any questions about this general guideline? Okay? So let's look at this one. This is the code you saw before. Okay, this is the code. There's always going to mirror. What happens when this code attempts to mirror picture around the vertical axis where the width is odd? Like if the width is 1, 1, or 3, would this work? A, B, C, D, E. What would you say? Okay. It seems like the even width would work, right? How about odd width? Would this work? All right. Let's see. Vote in. Okay, let's vote in. Is this gonna work? We will stop the vote. We'll stop the vote. Okay. Out of all the votes I've seen, if you look at it, B is the most popular choice. Yeah, well, a lot of us say it will mirror, but there is going to be a problem. Let's verify it. Okay. So we'll verify with the smaller pictures, maybe with 5. Right, so it's easier for us to measure. So if width is 5, this mirror point will be 5 divided by 2. The mirror point will be 2. Remember, it's integer division. Okay. So we say I goes through the entire rows, all the rows. So in other words, if it works for one row, it will work for all the rows. Column goes from 0 to 2. So if you look at the column number, this is W equals to 5. So from 0 to 2 means 0 and 1, right? So the potential values for J is 0 and 1. If I have 0, 0, where does this go to? It goes to with minus J minus 1. So if I have a 0, 0, it's going to go to 0 and then with, which is 5, minus J, which is 0. So this is IJ, right? Minus 1. So you go to 0, 4. Looks okay. The next thing, I will have 0, 1, which is this one. Goes to 0, 5 minus 1 minus 1, which is 3. And that's it. Those are the 2 pixels that we have. So now it works. So it works for the first row, it's going to work for every row. Then A is the right answer. A is the right answer. Okay. Are there any questions? So this one will work out fine. Okay. I can see your concern and say, well, what if it's odd? It will work for both even and odd. Okay. So it's a correct piece of code. Let me give you a quick demo, okay, of how this one works. For example, right, so I have a picture of everyone on the Zoom chat. Let me see. Let me take a screenshot of that. Take a screenshot of this thing. Okay. Let me save it. Okay, I'll just save it over there. Now, let's go to our coding here. Let me upload that picture. Desktop. This is the one. So it's a screenshot of everyone on Zoom right now. Okay. So mirror from left to right or right to left. Let me change it. It's too long. The name is too long. I don't want to type it in. I'll say sample.jpg. Okay. So that's our sample picture. We'll just write the code. I'll copy it in. Okay. This is bad. So make sure tabulation works. Let me load the image. Image equals to load image sample.jpg. And if you run it and then I save it, save image, let's say mirrored.jpg, right? So if you run it, Python demo.py. So this is sample, and this is mirrored. Did I have a where did it mirrored? Interesting. So this is our sample, and we're mirroring left to right. Is it? Oh, sorry. We're mirroring from left to right. That's correct. So we load this thing. It looks like it just mirrored the left column, is it? This is what we have. Oh, I see why. If you look at the screenshot, there's this white region. There's this white region, you see? So it's basically cutting out this part. So our mirror point is here because there's this left boundary here. So this region is mirrored to the right. That's why you see this weird shape in here. There's this white region on both sides, and this column is mirrored. So it's just a screenshot issue. If we mirror the bear, it's gonna look better. Okay, just change it into bear.jpg. If we run it, so this is bear, this is mirrored, so the bear gets thinner. It will work. Okay. Any questions? So it's symmetrical. It's symmetrical, right? As you can see, it's very symmetrical, right? You can also say, well, what if I want to mirror from right to left? Do we have an exercise to mirror from right to left? No. So, but what if I want to mirror from right to left? This is the code we have, right? So what would you do to mirror from right to left? I put this code in the Zoom chat. So I want you to modify this code such that we'll mirror from right to left. Right now it's from left to right. How about right to left? What would you change in here? Okay. I'll give you 1 minute to try to do this. So can you do it? I put in the solution for this one in here. You can try to write the code for this one. Okay. You can paste it into any of the repos, not repos, any of the coding challenges that we have. You can also use this one. This is the coding challenge that I'm currently using. Okay. How do I mirror from right to left? All right. So how do I mirror from right to left? In fact, it's very easy. I just say going from the mirror point to image width. Remember, this doesn't include this image width. And if you run the code, you just need to change this part. If you run the code, it's gonna mirror it from right to left. So this is the mirrored result. So the bear getting a little bit fatter in here. So because you can't fold it from right to left, you fold this right side to the left side. That's how it goes. Look at the difference between these two. Okay. And this region, you may say, well, how come you don't need a +1 or anything like this? You don't have to. You don't have to. Okay. So let me give you an example here, right? If I need to mirror from right to left, if this is what I have, if width equals to 3, the mirror point would be width divided by 2, which is 1. So it goes from 1 to 3. 0, 1, 2. So what we are doing here is the range for the column is 1 and 2. Right? So what we copy in here is we grab this pixel, we copy it into 3 minus 1 minus 1, which is 1. In other words, this pixel is copied in to itself, which doesn't change anything. Okay. The second part is when j is 2, I'm looking at 3 minus 2 minus 1, which is 0. So 0, 2 would be copied into 0, 0. It's going to work out just fine if it's odd. If it's even, 0, 1, 2, 3. The mirror point is W divided by 2. W is 4. 4 divided by 2 is 2. So we are looking at going from 2 to 4, which includes basically this cell and this cell. 2, 3, right? Because it doesn't include 4. When J is 2, with -2 minus 1, which is 4, -2 minus 1 is 1. So 2 is copied into 1. When J is 3, 4 minus 3 minus 1 is 0. So this one, if you simply go from mirror point to the width, it's going to allow you to mirror from right to left perfectly. There's no problem on that. Very similarly, if you need to do bottom up, you manipulate the height or top down, right? So that's how it goes in here. So half point, right? Left to right goes from 0 to half point. Right to left going from half point to the entire width. You can kind of migrate this idea to the height, if you try to mirror top down, bottom up. Preference about this? Okay. So that's one thing. Coming back, there's one more concept that we need to discuss about mirroring, which is in here. Okay. So if I want to mirror around a horizontal axis, which is this green axis, assuming this picture is 4 rows, 6 columns, what are the first XY? Well, I shouldn't say XY. I should say row column pairs that will be mirrored in here. So in what order can I mirror these pixels? So 00 to 03, for example, that's maybe one thing, or 00 to 30, or the other ways. So what are the first coordinates for the top, bottom mirroring here? Let's vote in. Sorry, let's vote in, please. Okay, so please vote in. Vote in what order can I copy these cells? I'll give you some help. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. So you know the row number, column number. All right, looks like we totally disagree with each other a lot on this one. Out of the votes we got, is almost identical to each other. Okay. All right, so let's check. So we want to mirror from top to bottom, right? Top to bottom. So the first thing we can try is 0, 0 to 0, 3. This mirroring seems to be working, top to down, right? And then 0, 1 to 0, 2. 0, 1 to 0, 2. Sorry, 0, 1 to 0, 2. 0, 1 to, sorry, I think I made a mistake in drawing the first example in here. So 0, 0 to 0, 3. Sorry, 0, 0 to 0, 3. This is what we have. Oh, that doesn't look right. So A is not right. 0, 0 to 0, 3 doesn't look right. Now, how about the other ones? So A is not good. How about B? 0, 0 to 0, 3 again. But B is also not right. Row 0, column 0 to row 0, column 3. That's incorrect. 0, 0 to 3, 0. 0, 0 to 3, 0. That one looks right. 1, 0 to 2, 0. Remember, it's row number, column number. It's not X, Y. Okay. And then 0, 1 to 3, 1. 0, 1 to 3, 1. So you're kind of copying it to take care of the first column and then take care of the second column. So C is good. C is good. How about D? 0, 0 to 3, 0. This part. 0, 1 to 3, 1. 0, 2 to 3, 2. But D also works. This one is like do it column by column. This one is row by row. And since I'm copying the things from one region to the other, it doesn't really matter that much. Like in what order am I going to copy, right? It looks like just like you have two dishes, you can finish the first dish first and then eat the second dish or the other way around. It doesn't really matter in what order. They're going to end up in your belly anyways. And so it's the same thing here. You can copy it row by row or column by column. But in reality, it is faster to copy it row by row. This will be faster. It's mostly because these cells in the same row are next to each other in memory in general. So just like if you think about a mailman have to deliver mails to two different neighborhoods, what does he do? A mailwoman. So the way to do it is usually the person go to one neighborhood, finish all the houses in this neighborhood, then move on to the next neighborhood. You can also have deliver mail for the first house in here and then drive to the other house over there. And then come back and then do that. So it's not efficient if you do something like this. No one will do that in practice. In here is the same thing. If you can do it row by row, in general, it's faster. Because these cells in the same row, they are in general next to each other, so it's very convenient for you to just hop on to the next cell. If you do it column by column, they are not next to each other, so you are constantly moving across different regions in the memory. Right? So we say column by column, we say this is column major. Row by row, we say this is row major. Okay, so just some terminology in here. You should know that both of them would achieve the goal. And you should be able to identify, is this row major or column major? Right? And then you should also know that the row major in general is faster than column major. Okay. Are there any questions about this? All right. Let's work on this one. Okay, so can you complete this code? So the code is copying it row by row, row major. Okay. So this is what we have. So how can we do this? How can we do this? So fill in the blanks, row major, column major. Okay, so let's get started in here. Okay. Let's get started in here. So give me a vote once you're done filling in the blanks. Three of us are done. Okay. All right. Four of us are done. Okay. Has to be row major. So how do I determine whether it's row major or column major? All right. Let's work on this one. Okay. So how do I determine it's row? Well, this one is row major. I need to copy it row by row. In other words, row by row, it means the row doesn't change. The row number doesn't change often. Right, so the row number should be the outer loop. The index on row should be outer loop because the outer loop's counter doesn't change often. So I in range of something, so the outer loop has to be on row. And since it's copied top down, so row number I goes from range of image height divided by 2. Put J in the range of image width. Right, so height and width. We say grab a pixel from top. On the bottom, they would have the same column number. Because if you mirror from top to down, they have the same column number. The row number is image height minus I minus 1. So normally it's like the full dimension minus that coordinate minus 1. This would make it a row measure. This would make it row measure. Okay. Any questions about this part? You may ask, how do I make a column measure? If I want to make a column measure, then you can, so the easiest way, we'll just swap these two for loops. That's it. Just put this outside, this thing inside, you have column measure. Okay. Any questions about this part? So the outer loop is the one that determines whether it's row measure or column measure. Okay. All right. I didn't see any questions. Now, the last few topics, the first topic in here is flipping. Okay, flipping. So the idea is it's different from mirroring. So if this is the original picture, it's a mirror it. You mirror from left to right. You basically copy this region into the right side, so the whole thing is symmetrical. End up with a symmetrical picture. Flipping means you rotate this 180 degrees. It's like you turn it 180 degrees. That's what it is. Okay. So if that's the case, you basically this pixel used to be right, now it's left. It's like if a person used to be looking to the left and now it's kind of mirrored. It's not mirrored, it's kind of flipped. The person is now looking to the other direction. So it's like rotate this one 180 degrees, and that's what you end up with. So how do I flip a picture? How do I flip a picture? The way that you should flip a picture is something like this. It's very similar like mirroring, right? Mirroring means you copy this thing over there, right? That's how you mirror it. Flipping means you swap these two pixels from the source to the target. Now you swap them instead of copy from one side to the other. That is the idea. So if I mirror in the middle, I have the width and the height. I have the half point, so it's extremely similar like mirroring. And then I have this Nancy 4. I grab the pixel on the left side, I grab the pixel on the right side. You see their coordinates are almost identical like before. So I basically need to swap them. I need to swap them. So how should I do this? A, B, C, D, E. Which one looks right in here? A, B, C, D, E. Right, so for this code, what should I do next? What should I do next? right, so the votes are again all over the place. Let's check, right? So we need to swap them, right? So we will assign this tuple there. So we have to cross it like this, right? So A or B, I think either way is fine. We need to do both. We can't say I just do one of them. So I would say E is the best answer. C or D, they're both good. A and B are okay, but you need to do both. You need to do both. Yeah, there is a question. Is there a question? All right, maybe it was an accidental unmute. Are there any questions about this one? So that's it. Instead of copying in, you just swap them. You swap them. All right. So this is flipping. I think let's take a break. Once we come back, we'll have one more exercise. I'll give a quick demo about flipping, and then we'll look at some of the out of bound or off by one errors that you should watch out for. Okay. So let's take a break. Come back 1 o'clock. Come back 1 o'clock, everyone. Okay. So break time. Break time. All right, folks, let's get ready for the last session today. Okay. So let's wait until it's 1 o'clock. Okay. Let's do a quick demo and then we'll move on to the remaining part of material. Okay. This part here. All right, so the last section, we finished flipping and we have one quick exercise, then we'll talk about off by one box. Just be careful on that. Let's finish first the demo for flipping. So you have the pixel on the left side, your pixel on the right side, and then you just assign them image ij equals to rr, gr, br. Breakpoint. Image I, image width minus j minus 1 equals to rl, gl, bl. And that's it. So this one should be flipped. Okay. I'll use this picture. I'll use swan. Right, swan. Right now, the head is on the right side. It's looking to the right. If you flip it, the swan's head will be on the left side. Okay. So let me open up swan.jpg. And then let's run it. So you have the original swan, which is this one, and the flipped. You see, the swan is now looking to the left. Used to be looking to the right. Once you flip it, it's not going to make it symmetrical, right? It just kind of turn the entire picture 180 degrees. You get this part. Are there any questions about this? All right. So this is the part where we have the flipping. Okay. Very similar like mirroring. One quick exercise in here. So sometimes you will see like this kind of code, right? So it looks weird. Well, what does it do? The best way for you to figure out something like this is to give yourself some small pictures and see what it does. So trace the code and see what it does. Unfortunately, you can't use Python tutor to trace a code like this because it needs the special package like the 8a, and Python tutor doesn't support that. So you have to trace this by hand. So what would you say this code does? A, B, C, D, E. Take your time, right? So really trace the code to say step number 1, step number 2. Give yourself some examples, right? What does this code do? You have to be careful, right? You can't say, oh, it mirrors from left to right. But if you're off by 1, it doesn't. So, but it doesn't mean it won't mirror it properly, right? You just have to make sure you trace the code properly. Yeah. The most popular choice is E right now. Some weird thing. But just because the code doesn't look so organized, it doesn't mean it's a bad thing, right? So you got to really chase it and see if you trace the code line by line on a sample picture, what does that do? All right, so let's check this one, right? So we have the if you look at the vote, B, D, E, nobody voted for A. Let's check. Okay, so which one might be right? So how do I do this? I first come up with some pictures, maybe something like this, right? We'll see how it goes. So the height is 4, width is 3. We say width is 3, height is 4. Magic equals width divided by 2. Width divided by 2 is 1. So magic is 1. For I in range of image H, in other words, the height. So I is the row number, so it covers the entire height. And then counting down equals to width minus 1, which is 2 to start with, right? We say then for J in the range of magic, magic is 1, range of magic, which is range of 1, just includes one value, which is 0. Basically, J would be 0 in here. I'm grabbing I, J. So the first thing is 0, 0. I'm copying it into I counting down. I is 0. Basically, I'm looking at I is 0 here, j is 0. So I'm copying it to 0, 2. So this cell is copied over there. And then I say counting down minus equals 1, decrease by 1. So now it's 1. The next thing I do is I'm done with this for loop. Right? I'm done with this for loop. Now I would become 1. So I would take a value of 1. Counting down again is 3 minus 1, which is 2. So it looks like it's doing this thing again, just have a different I. So it's kind of mirroring, right? It's kind of mirroring from left to right. So C looks good. C looks good. How about if the picture's width is even? So height is 4, width is 4. The magic number is 2 now, right? The magic number is 2. So I goes entire height, so I would take value of 0, 1, 2, 3. 2, 3. 0, 1, 2, 3. Right, so magic is width divided by 2, which is 2. So magic is 2 in here. Then j would be value of 0 and 1. 0 and 1. So we grab ij, which is 0, 0, copy it into, so my counting down is width minus 1, which is 3. So copy it into I counting down, 0, 3. Copy it in here. And then this counting down is changing into 2. This for loop would run twice. So the next round, j is 1. So I'm looking at 0, 1, which is in here. Copied into 0, 2. So this is also mirroring from left to right, which looks right. So the correct answer, in fact, is C. It mirrors things properly. So for those who voted for B or C, especially for those who voted for B, it works for both odd width and even width. So it's good. Most likely it's not gonna do the top down, right? Because top down, in general, you have to do half of the height. You only cover one part of the height, not like the entire height. So C is the right answer for this one. Any questions? As you can see, geometry would take some practice, and you have to be very patient. Trace the code one statement at a time to see if it does what it's supposed to do. And this is what you're gonna need to do for PA4. For PA4, you're gonna flip a certain region in a picture. You have to make sure that you don't have off by 1 problems. Okay. Any questions about this exercise? Okay. So the last exercise is about off by 1 problem. In other words, you're trying to do something on a region, but you are doing it one size bigger, one size smaller, and it's not going to be correct. So you have to be careful. And the key to avoid these off by 1 errors is a very important, accurate understanding of range, right? So if you say the range is from 1 to 5, what does this really imply? If you say it's range 40 to 50, what does this imply? What are the values for j? So what is the size of the red box that we're gonna create in here? What's gonna be the width? What's gonna be the height of this box? Okay, so let's do a quick vote on this one. So I'm creating a pure red box. All right. So a lot of us voted for B. Now, what does this I indicate? So the most popular choice is B. Let's check it, right? So I is, well, I is the outer loop. It doesn't mean it's on rows, right? The only reason that I know for sure it's on rows is because I appeared in the first index of this 2D list of tuples. So I is on rows, J is on columns. Rows indicate height, columns indicate width. So 0 to range 1 to 5, it means 1, 2, 3, 4. So there are 4 things. So the height is 4. In here, from 40 to 50, 40 all the way to 49, that's 10 things. So it's not 9 by 4. Unfortunately, that's incorrect. It's in fact none of the above. So height is 4, width is 10. Any questions about this? Be very careful. So range A to B, how many things are in between A and B? Like how many legitimate values is between this range is B minus A. If it's 1 to 5, 5 minus 1 is 4. If it's 40 to 50, 50 minus 40 is 10. So it's height is 4, width is 10. That's in general how it goes. If it's an easy, simple range, if you have a range, for example, range of 10, the width in here is also 10, right? So it's 0 to 10. 10 minus 0 is 10. Okay. But you should also keep in mind the right side is not included here. Any questions about this? So be very careful. Okay. Let's try this one. I want to create a box. The nested for loop would allow me to create a black box of width W and height H. Which one or which ones of them would allow me to do this? Be careful with off by 1, and also do not confuse row number, column number. Right, so row, column, what do they indicate? Vote in whenever you're ready, and I think this is the last vote we have for today. Okay. Cursor away. Which one or which ones of them? Remember the trick I told you? If it's going from one number to the other number, is there a difference? Is there a difference? All right, so a lot of us said E. More than one of them. All right, let's check. Let's check. The first one, rho is about the height. And if you look at h plus 1, definitely this is wrong, right? Because h plus 1 is going to give you a box. This is the box of h plus 1 by w plus 1, because they start from 0, right? 0 to h plus 1. H plus 1 minus 0 equals h plus 1. But this one doesn't work. Well, this one will give me a h by w, right? So rho is between them. The total number of data between 10 and h plus 10 is h plus 10 minus 10. Because the right side is not included, so you don't have to add 1 to it. So it's just h, similarly on w. This one is also h by w, right? So I think E is right. B is good. C is good. How about D? This one is a little bit hard for you to figure out, right? So it's going backward because this is the step size. This is the step size. So it's h to 0, and then the step size is -1. So it goes from h minus 1 all the way to 1. So how many things are between 1 and h is exactly h. So B, C, D, they are all good. They all create a box of h by w. It just is filling in this box in different orders, right? And also compare B with C, just the different locations of the box. Right, this one is at the location 10 to h plus 10. Here, just from 0 to h, from 0 to w. This part is very similar to C, except it's kind of filling in the box. Instead of top down, left to right, is bottom up, right to left. So you're just filling in the box in a slightly different order. So E is the right answer for this one. B, C, D, they're all good, other than A. Okay. Any questions about this part? So let me summarize what we learned today, okay? So for today, we started with a filter, right? So filter, you just go through the entire picture, you do something on RGB. The other thing you can do is geometrical processing. It's like mirroring, flipping, right? The last part of the exercise is to avoid off by one error. Your box is one size too big or one size too small. You have to be careful on that. Beyond this is everything I've planned out for today. Are there any questions about the material, or are there any questions about the midterm that folks want to ask?
I have a question about the midterm.
Okay, hold on. Yeah, which question do you have?
So, for me, it was question 9.1. It was objects versus non-objects.
9.1. Okay. Hold on. Nine 9.1. Okay. So what are objects, right? So based on our class, we said tuple and list, they are objects. Int, string, float, they are not objects. That's the answer.
Okay. Okay, thank you.
Any other questions about the midterm?
I also have a question about that question.
Okay.
What would we consider like int, string, and float?
They are technically considered to be basic type or primitive type, okay, based on what we discussed in class. If you look at various Python documentations, they say everything in Python is object-oriented, but we discuss them as simple data types, so we call them primitives. Any other questions? for the midterm.
Could you also explain 9.3?
9.3. Select the true statements about the following code. Let me show you. Let me take let me see manage submissions. I'll create a new submission so you can see it here. Right. So 9.3. Where is it? This is the code. So we have this function, and then we say xy, and then full xy. Number one, this x and that x, those are totally two different x variables. They may have the same value in the beginning, but they are totally different variables. So the x variable in full is different from the x variable at line number 6. That's correct. X variable in the full is no, then this is wrong, right? The function call to full at line 8 passes the variable x and y themselves. That's incorrect. You pass the values of x and y to the function. In other words, they are arguments. Arguments are always values. So this x is given to that the value of this x is given to this variable x. The value of y in here is given to that variable y. So this is correct. The return statement in line 5 update this x to be 6. That's incorrect. When you return something, you always return a value. So this value of x, whatever x is, I think is 6. 6 is given back, but we didn't assign it to any variable. So that return value is thrown away, is discarded. So this one is incorrect. If we print z at line 9, will cause error. If we print z in here, it will cause error. That's correct, because we don't have a variable z in the global frame. There's a z in this function, but it's not part of the global frame. So at least this part is right. The return state, if we print z at line 9, it causes error. But if we change line 5 to return z, if we change this to return z, it won't help. It won't help. You are never gonna return a variable back. You always return a value. So this one is incorrect. How about this one? Once the full function call is done, all variables created in the full stack frame are destroyed. So there are 3 correct answers. These 3.
Okay, that makes sense. Thank you.
Any other questions?
I had a question on 3.2.
What is the value of x after this one runs? We're not asking you the result of x. X is still a float. You type x, the value of x is typecasted into an int, but x is still a float, a.0. Any other question?
I had a question about 9.2.
9 point. I think we just talked about it. No. Okay. What's your question on this? How many stack frames are created? Let's count. Let me read it. Include the global frame. Okay. So if you look at it, there's a global frame for sure. When you call full, 1 frame is created. When you call bar, it's gonna first call full bar. Full bar is gonna call full twice, and full is here, it doesn't call anything. So full, this one would have 1 stack frame. For bar has its own stack frame. It calls full bar, which is another stack frame. Full bar calls full twice, that would create 2 more stack frame. So in this second call, I think I need to write it down. Otherwise it's hard. So this one is 1 stack frame. there's one global. For bar, this is one, and this one is going to be another one. These two will give me two more. And if I call full in here, full will give me one more frame. So it's 1, 4, 5. So this bar would have 5. This one will have 5. Why is it? So this is 5. This is 1. For full bar, if I call full bar by itself is a frame. Calls full twice, that's another 2 frames, so that's 3. And then there's one global. So it should be 10. We should have 10 frames in here.
Thank you.
Any other questions?
Can you go over 4.2?
So I want to print out 2, 5. If you look at, so x is 2, y is 5. So I need to print out 2, 5 in here. Those are the only possible ways that I will print out 2, 5. And if you look at this if and this else if, there's no way both of them can run. So it should be none, none, none. Because those are, you have to print out x and y to give you 2, 5. Sorry, my bad. My bad, I didn't read the card. You want to get to 2, 5, but x is 2, y is 3. So you want to print out this thing. You also want to print out this thing. Right? This would print out the 2, this would print out the 5. So the way that you want to do it is this part must be true. Right? As for what this part is, it doesn't really matter because if the first part is true, the second part doesn't matter. In order for me to print out x plus y, this part must be false. So possibly there will be 2 answers, true, true, false, or true, false, false. Both of them would work. So I think, sorry, this one. So it would be true, true, false, or true, false, false. So these two, sorry, these two would both work. The second part doesn't matter. Problem 7. Where's 7? So the equivalent, which of the following loops are equivalent to this one? So this one would give me a value of 1, 3, and that's it. So this loop runs twice. Yeah. So you just need to look at choice A, right? Does this give me 1, 3? No, this one is an infinite loop, so A is wrong. For B, so 1 will work, and then I becomes 3. So B would work, right? B would work. And then when I becomes 5, you're out. How about C? C would also work. So start with 1, and then I becomes 3. 3 would work, and then I becomes 5. This condition is false. So C would work. How about D? This one won't work because it's going to include 5. So when I is 5, it's still going to work, but in the original for loop, I equals to 5 doesn't work. So B and C are working. Any other questions?
I have a question on 11.1.
So you have these 2 tuples. Sorry, this is thing 1, and thing 1 is a tuple, thing 2 is a list. Thing 1 is a tuple, thing 2 is a list. Tuples are immutable. Let me zoom out a bit so you can see it. Thing 1, 0 is 1. Thing 2, 2 is, sorry, that's right. Thing 2, 2 is 3. thing 1 0 equals to thing 2 0, this would cause error because you're trying to change the tuple. This one won't cause error. Thing 1 equals to 4 5 6 is okay. Thing 2 equals sorry, neither of them is gonna cause error. This one is okay. This one is also okay. So because thing 1, thing 2, they are just references. So you can definitely change a list reference. You can also change a class reference.
Thank you.
Okay. There's one question about taking class for next year. You shouldn't wait for AB. So the question is, once I finish 8A, should I wait for AB? No. AB and 11 are pretty much the same thing now. Used to be different, but you should just take 8B or 11, whichever one works for your schedule. Okay. Any other questions? All right. So if there are no other questions, we will stop here. In order for you to get into CSE 11, I think you need to get a C or above. I think. Go to registration and see, like there's a thing UCSD CSE advising. I think they would know a lot more than I do. There are a lot of information, okay, class enrollment information and stuff. So come here, look at it. Don't count on my words. I think it's C and above. In order for you to take 11, basically you must get the credit for 8A. I think in order for you to get the credit for major class, it must be C and above. Okay. All right. So if there are no other questions, we'll call it a day today. Okay. I will see all of you next week. Don't forget the quiz tomorrow. Okay. All right.